What causes unintended side effects in Python functions? Imagine writing a simple function to add to numbers, but suddenly your program changes a list you didn't expect it to. That can happen because of unintended side effects. When you define functions in Python, they are meant to do specific tasks, but sometimes they can change things outside their scope without you realizing it. This is often caused by how Python handles objects and variables. One common cause is modifying mutable arguments. If you pass a list or a dictionary to a function and then change it inside the function, the original object outside the function also changes. This is because Python passes objects by reference, meaning both the function parameter and the original variable point to the same object in memory. So, if you add or remove items from a list inside the function, the list outside also gets updated. Another cause is using mutable default arguments. When you define a function with a default argument like a list or dictionary, that default object is created once and shared across all calls. So, if you modify it during one call, the changes stay for the next call, leading to unexpected behavior. For example, if you have a function with a default list and append to it each time, the list keeps growing. Changing global or non-local variables is another way side effects sneak in. If your function modifies a variable declared outside its scope, it affects the program's state beyond the function. This can make bugs hard to track because the change isn't local to the function anymore. Performing input and output operations or modifying external systems also cause side effects. Writing to a file, printing to the screen, or updating a database are actions that change the environment outside the function. These are often necessary but can lead to unexpected results if not managed carefully. To avoid these issues, use immutable data types like strings, numbers, or tuples whenever possible. These can't be changed once created, so they prevent side effects. If you need to modify a mutable object, make a copy inside the function before making changes. Also, avoid mutable default arguments by setting defaults to none and creating new objects inside the function. Limiting the use of global variables and passing parameters explicitly helps keep functions predictable. Designing functions as pure functions, which always produce the same output for the same input and do not cause side effects, makes your code easier to test and maintain. By understanding these causes and following these practices, you can write clearer, more reliable Python functions that do exactly what you want without unexpected surprises.